Now let's talk about the definition of infinite limits. Suppose I have the function f of x is 3 divided by x minus 2. If I look at the values as x approaches 2 from the left, I see that this function gets very, very large in a very negative way. So I say that it decreases without bound, or it becomes infinitely negative. If I look at the functional values as x approaches 2 from the right, then I see that they become very, very large, actually fairly quickly. And f of x, we say, increases without bound. This is what we will see as a positive infinity. Ooh, that didn't work. A positive infinity. And we're going to see that this becomes a negative infinity. Now, let's define what we mean by a limit being positive or negative infinity. The definition is up here, but I kind of just want to do it with the diagram. Suppose I have a function. If I pick a functional value m, and it doesn't matter what m is, no matter what m I pick, then if I get just a little bit closer to my point C, then I will wind up with a functional value greater than m. So it doesn't matter what m I pick, all I have to do is scooch closer to my point, and that value actually, and the functional value is larger than whatever number I pick. Now, be sure that when you see that equal sign, it doesn't mean the limit exists. It means the limit fails to exist. As a matter of fact, it becomes very unbounded, either in the positive sense or the negative sense. So, let's look at this one right here. The limit as x approaches 1 from the negative, from the left, of f of x is negative infinity. Oh, didn't do that very well. It's negative infinity because no matter if I get just a little bit closer, I'm going to wind up with a functional value that is even smaller than the one before it. Similarly, the limit as x approaches 1 from the right is positive infinity, which means it becomes unbounded in a positive way. Now for this one, we can actually say the limit as x approaches 1 of f of x is equal to positive infinity, because the left limit and the right limit are equal. They both become unbounded. Now this does not necessarily mean, although in this case it's true, that there's any symmetry about this line, simply that it becomes unbounded. Let's look at this function right here. The limit as x approaches 1 from the left of my function here. Now as I come in from the left, I can see it becomes unbounded in a positive way. While if I come in from the right, the limit as x approaches 1 from the right of f of x is equal to minus infinity. So you see very small changes in the function drastically changes our answer. And this example right here, the limit as x approaches 1 of f of x is negative infinity because this function decreases without bound on both the right and the left side.